Hello, my name is Thomas Turrell, and today I will be explaining a brief history of rocketry to the future of space exploration. The first human rocket launch. In the 1600s, Chinese Emperor Wan Hu wanted to go to the moon. Wan Hu decided that the best way to do this was to strap 47 gunpowder fireworks to the bottom of a chair and let them propel him to the moon. On the day of the launch, Wan Hu had 47 assistants help light all the fuses at the same time. As the fuses burnt up, a large explosion occurred, and Wan Hu was gone. In Chinese legend, Wan Hu successfully landed on the moon, and is now known as the Man on the Moon. Robert Goddard. In 1962, the world's first liquid-fueled rocket was launched. Although it only flew 12.5 meters into the air, it was considered a huge success and was the forefather to all modern-day rockets. From this launch, Robert Goddard became known as the father of all modern-day rocketry. Sputnik 1 and Sputnik 2. During the first space race between the Russians and the Americans, the Russians sent up Sputnik 1, a spherical satellite with 4 antennas. This satellite was the first man-made object to orbit the Earth. 2 months after Sputnik 1 was launched, the Russians launched Sputnik 2 into orbit, with the first living passenger, Laika the dog. Sadly, she passed away in orbit due to the cabin overheating and oxygen deprivation. Now to modern day. SpaceX. SpaceX rockets have had a drastic impact on space travel in the 21st century. SpaceX has the leading edge rockets due to the fact that they are reusable. By landing spent stages near launch centers, SpaceX is able to refuel, repair, and relaunch much faster than other space agencies. Other benefits to this is the overall cost of building and launching rockets is cheaper. Comparing the Falcon Heavy costing $500 million to build and launch the first time, with the second launch costing $97 million, and NASA's SLS costing $4.1 billion every launch, the Falcon Heavy comes out 8.2 times cheaper. SpaceX is also preparing to establish a colony on Mars. Colonies on other planets and moons are extremely important for the future of humanity. Colonies make deep space and in-solar system exploration easier. For example, if SpaceX were to form a base capable of creating rockets on the moon and were to build a rocket the same way we do on Earth, the rocket on the moon would have over six times the launch efficiency due to the lack of atmosphere and weaker gravity. Other benefits to having a colony somewhere else in the solar system is if the Earth were to be destroyed by some cataclysmic event such as an asteroid impact, the human race would still survive. Now to the future. The universal maximum speed of objects with mass is 299,792,458 meters per second, also known as the speed of light. As an object accelerates to near the speed of light, the object requires more and more energy to go faster. Every meter per second faster the object goes, the required energy becomes exponentially greater, and nearing the speed of light, the amount of energy required would be infinite. Einstein's equation E equals mc squared shows that the mass and energy are two sides of the same coins. Therefore, energy is mass and mass is energy. Using this principle, an object going near the speed of light gains mass with every joule of energy used. This is at the ratio of 1.11 times 10 to the negative 17 kilograms per joule. Therefore, an object moving at the speed of light would have an infinite mass and would require an infinite amount of energy. In 1994, Miguel Alcubierre produced a new method to propel a ship in space faster than the speed of light. Miguel's method effectively changed the geometry of space to create a wave in the fabric of space. This wave would contract the space in front of the ship and extend the space in the rear of the ship to create what is known as a warp bubble. Objects inside this warp bubble would experience no proper acceleration, almost like if it weren't moving at all. Since the objects inside the bubble would not be locally moving, this bubble allows for objects with mass to move faster than the speed of light. Effectively, the Alcubierre drive creates a pocket in space and moves the pocket faster than light, while the contents experiences no acceleration. With the objects not moving inside the bubble, they would not succumb to relativistic effects such as the gaining of mass the faster the bubble is moving, or time dilation. Thank you for listening. I hope you enjoyed the video.